Assalamualaikum warahmatullahi wabarakatuh. Today, I'm going to present you about our group assignment, BERN Digital System from group 11. My name is Mohamad HISHAM. So, my team member is Mohamad ZAHID bin ISHAK, Mohamad FAHIM bin Mohamad SHAROFI, and Mohamad HAZIQ bin Mohamad NAZLI. So, for question 1, 4 to 16 decoder. Introduction. A 4 to 16 decoder is pivotal in applications like memory addressing, data multiplexing, and control signal generation. It takes a 4-bit binary input and activates one of 16 output based on the input value, ensuring only one output is active at a time. This capability is essential for binary to one-hot encoding in various system design.
So this is the circuit of 4 to 16 decoder. The 4 to 16 decoder in digital electronic translate a 4-bit binary input A3, A2, A1, A0 into one of 16 output line Y0 to Y15. It uses AND and NOT gates to activate a specific output based on the input combination. This implementation ensures accurate decoding for each input, crucial for tasks like address decoding and memory selection in digital system. Verilog facilitates precise representation and simulation to validate the decoder's functionality, ensuring reliability in practical application. So this is the waveform. A waveform is a visual representation of how signals, inputs, and outputs change over time in a digital circuit. For a 4 to 16 decoder, the waveform shows the relationship between the input signals A, B, C, D and the output signals Y0 to Y15. For the output, Y0 to Y15 are the 16 output lines. Only one of these lines will be high at any given time, corresponding to the binary value of the inputs. The rest will be low. This is the Verilog code. The Verilog code defines a 4 to 16 decoder module that takes a 4-bit input A and generates a 16-bit output Y. Upon any change in inputs, Y is reset to all zeros. A case statement evaluates A, setting the corresponding output bit in Y to 1 for each binary value of A from 0000 to 1111. A default case resets Y to zeros as a safety measure. This simulation confirms that only the correct output line is activated for each unique input combination, verifying the decoder's functionality. This is the test bench code. The test bench TB decoder 4 to 16 validates the decoder 4 to 16 module by using a 4-bit register A for the inputs and a 16-bit wire Y for outputs. It instantiates the decoder 4 to 16 module, connecting A to its input and Y to its output. This approach comprehensively tests the 4 to 16 decoder, ensuring it accurately maps each 4-bit input to the correct single-bit output as designed. This verification step confirms that the module's reliability and correctness for practical applications.
For the conclusion of the number 1 is the Verilog implementation of the 4 to 16 decoder along with its dashboard demonstrate the module functionality and correctness. It translates a 4-bit binary input into a 16-bit output where only one output line is high based on the input value. Through meticulous simulation and verification, each input combination that one has called 0000 to 1111 was tested sequentially, confirming the module reliability. This process underscores the importance of rigorous testing in engineering digital circuit design performed as extended.
For introduction for question 2, the design and verification of combination logic circuit are essential steps in digital electronics, enabling the realization of specific output waveform based on given input combination. This report focuses on designing a combinational logic circuit that produces a specific output waveform. as depicted in figure Q2. Starting with the analysis of the input combination that result in the desired waveform, the theoretical design process involves identifying appropriate logic gates and configuration to achieve the required output. Following the theoretical design, the circuit is implemented in Verilog, a hardware description language widely used for modeling and simulating digital systems.
This is the logic circuit. The refined Boolean expression serves as a blueprint for designing a comprehensive logic diagram. This diagram visually represents the interconnected logic gates necessary for implementing the circuit. It outlines how various logic elements, such as AND gates or gates and NOT gates, are structured and connected based on the Boolean expressions derived from the circuit's requirement. This detailed representation ensures clarity in the circuit design process, facilitating accurate implementation and verification of the digital logic system. For the waveform is segmented into distinct time intervals, each corresponding to the different binary input combinations. This input transition causing the output to alternate between high and low states. Critical points in the waveform coincide with changes in the input combinations, directly influencing the output state transitions. For the Verilog code, here is our Verilog code for design, and the test bench for the combinational logic circuit simulates and verifies the Verilog design's correctness. It includes display statement to show the current values of input A and outputs Y. Aiding in verification, matching the expected output waveform for each input combination confirms the design's accuracy. This systematic approach ensures the combinational logic circuit functions correctly, validating the Verilog implementation's output based on the input conditions.
For the code, the batch code, that one has module combination logic that has three input via A, input via B, and input via C, and output via X. Assigned as A, B, and C. That one and module. The Verilog code for the combinational circuit generate an output waveform based on input combination. It uses an always, block, and case statement to ensure previous output transition. A test batch simulation simulate the circuit by applying all input and verifying if output Y matches expectation. This method confirms the Verilog design accuracy and ensure the circuit function correctly, producing an expected output waveform. And the conclusion for question 2. In conclusion, the 4 to 16 decoder Verilog design and verification illustrate its effective modeling and simulation in digital system. Using truth table and logical equation, we ensure accurate design decoding of a 4-bit binary input into 16 output. This method simulation validate the Verilog code, confirming output correctness across all input combination. Alright, thank you for BADRUL 11.